Hey yo, got a new paper up. Stellar metamorphosis, stellar shrapnel exclusion zones in the WT diagram. Exclusion zones are outlined and explanation is provided as to why this is important to the development of 21st century astrophysics. The zones are in line with the general theory and can be used in a dynamic fashion. These basic astrophysical facts are up for revision and refinement. In short, ring material from Saturn could be pieces of the Earth's ancient oceans. This has never been hypothesized before. Maybe it has, but there really wasn't any solid reasoning behind it. As well, the exclusion zones I have in the paper are as follows. You have the mass exclusion zone. What this means is given a star at a specific point on the WT diagram cannot have shrapnel and impact remains be more massive than the star itself. So essentially that would be like taking two rocks, smashing them together, and then the shrapnel from those exploded rocks being more massive than either of the two rocks that originally had slammed into each other. That would be a direct violation of the conservation of mass. So basically the mass exclusion zone, given a few examples that I've outlined in here, this is more complex explanation to the mass exclusion zone. But for the most part, the object will not be more massive than the originating body. You have to start with more mass, and the mass is always lost as the star evolves along its transformation curve. And the age exclusion zone is self-explanatory. You can't have two rocks slamming into each other and then that material being much younger, or much older I should say, than the oldest material that collision had happened. For instance, if you have a billion-year-old rock and a billion-year-old rock slamming into each other, it doesn't make a 2 billion-year-old rock. What you're going to have are pieces of a billion-year-old rock. You're not going to have a 45 billion-year-old rock because of 1 billion-year-old rock slamming into another. And that's basically what the age exclusion zone is. You're not going to have objects older than the object that had originally collided from its parent material. The parent material the material that comes from the parent body cannot be older than the oldest portions of the parent body itself. That's as about as complex as it gets with that. And that being said, the reason why I had to make two exclusion zones is because this area right here is where shrapnel can occur, both less massive from the y-axis and younger than the parent body itself. And this is very important because the DH ratios, and I didn't spell that out as well as I could in this paper. I think I'll have to rewrite this paper. But basically it means that if they find, and they have found, that the ring material from Saturn is very, very old. It's as old as the Earth, if not a slight tad bit younger. And Saturn's DH ratio says Saturn, using this theory, is about 590 plus or minus 141 million years old as it is right now. So you have a very young object, Saturn, and you have a whole bunch of old, small shrapnel making up the rings surrounding it. And that being said, that is in line with the mass exclusion The material is smaller than Saturn. Clearly, it's made up of small icy particles and rocks, but it is not in line with the age exclusion zone, meaning the material that Saturn is composed of in the rings is much older. It's over here versus Saturn's location. So this is not Saturn. Saturn would be over here. But granted, Saturn cannot have rings that have come from Saturn that would be older than Saturn itself. So that means the age exclusion zone says that the rings Saturn is made of, or Saturn has, came from some other body that didn't come from Saturn. So that gives us another option. It says, well, hey, if the rings didn't come from Saturn, that means an object either had a near miss, collided with something in Saturn's orbit, around Saturn, or there was something completely orbiting Saturn that was being ripped apart. And we have evidence of the object that was being ripped apart because that's what the ring material is made of, before Saturn had lost it from some body escaping Saturn's gravitational field. Now, the next part of this is going to take a lot more imagination, but I had to write this down because it shows you how interesting this really can get. Now, given Saturn is 590 million years old, plus or minus 141 with its DH ratio, but the ring material is very old. Now, if the ring material's DH ratio, and I haven't been able to find this, if the ring material's DH ratio is 1 over 6,800, so 1 deuterium for every 6,800 hydrogens, and Earth's mean, this is the VSMOW, is Vienna Standard Mean Ocean Water. So they standardized the DH ratio in Earth's ocean water is 1 deuterium over 6,250 hydrogens. Now, if you remember from my previous papers, the lower the ratio, so this material would be older than this material. By how much? Well, using the math I use in my other papers, we're looking at Saturn's ring material having been 366 million years younger than the Earth's water. And granted, Earth was, Earth had, the same ratio as that ring material is before the ices had trapped the D and H, the deuterium to the hydrogen trapped, so that that ratio wouldn't change after the ice froze. It would be crystalline. The only way for the deuterium and hydrogen to change its ratio is for the lighter hydrogen to escape via a gaseous type configuration. Furthermore, 366 million years ago, meaning Earth, or whatever interaction that happened to make Saturn's rings, happened 366 million years ago, which places Saturn as being 224 plus or minus 141 million years old, which is firmly between orange and red dwarf stages of evolution. So which means the rings have been there for a very long time and were formed when Saturn, let me erase this part right here. Okay. They were formed when Saturn was way the hell up here. So whatever caused those rings to be formed, some object, some ocean world, flew past it, got ripped apart, and then went somewhere else and kept on evolving for a very, very, very long time. But 366 million years is only a little jump. It's right here. That's all I got. And this is really cool because we now can officially look at Saturn, at the stars, at the planets, as all the objects in the solar system, as being much more complex and amazing than any astronomer or astrophysicist could have ever imagined. And it places our ability to take 100 million years and sort of allows us to say, oh, okay, 100 million years, what's the difference between that and a billion years? Well, that's 10 times older. It has us to think in those really, really large numbers. Because 100 million years is an extremely long period of time. It's 100 times longer than a million years. And just to put things in perspective here, they say humanity itself evolved from our hominid-like cousins who were, weren't that bright and didn't look like us. Maybe about 8 million years ago. It took us about 8 million years to get to this point from our very ape-like cousins. It's just 8 million years. Now to think 100 million years, well, crap. And then a billion years. And it's like, it's just very different. This is a completely new worldview. To think Earth was in orbit around Saturn at one point, when Saturn was a red dwarf star. That's absolutely incredible. Nobody's ever thought of that. Nobody. Where was Jupiter at? Sun didn't even exist. What objects were always in orbit around Saturn? So many more questions can be asked now because of our ability to look at these things in a much richer light, a much different light. In the way that it takes our mind away from, the dogma. Oh, it all formed in a big disk. All right, you guys.